Okay, so chapter 21 is about induction. Induction of what? Of current, of electric current. So the great question, which is a natural question, is the following. If we have current, we saw in chapter 20, around the current we create a magnetic field. Okay, so how about the other way around? If I have a magnetic field, can I create current? Okay, so that's the big question, and that's a fantastic question because if the answer is yes, that means we are going to have electricity. And electricity is around our lives every time. All right, so this was a question asked by Faraday and others working on this, but Faraday is a main character behind these developments. So the question is again, I repeat, can a magnetic field somehow induce an electric current? What did they see? So this figure here is trying to illustrate the idea. On this left side, we have a wire, okay, connected to a battery. So we have a potential difference, so connected to a battery. So that means we can have current here. If I close this circuit, if I close this switch, I'll have current. All right. I know that around current, I create a magnetic field. Okay, on the right side, I have just a wire. It's not connected with any battery. Okay, it's just a wire. What we want to know is, once I close this switch and I have then current, so I have magnetic field, can this magnetic field created on the left side induce or not a current on the right side? What did they see? Well, after I close this switch, wait a little bit, I have steady current. Steady current means around it a constant magnetic field. Constant magnetic field, a steady current, does not create any current on the right side. So no induced current. However, right at the moment where we close the switch, so closing the switch means going from no magnetic field to having a magnetic field. So during this change in the magnetic field, then yes, we induce a current. Okay, and the same thing the other way around. Suppose I had this switch closed, so I have steady current, but as I turn off, now if I open the switch, so I go from presence of magnetic field to then no magnetic field when I close the switch. During this change, again I induce a current. Okay, so this is what the text is saying. A constant magnetic field produces no current. But as I'm changing the magnetic field, then yes, we induce, we created this electric current, which we then call induced current. Okay, what are we going to do next? Before discussing with you this second slide, what I'm going to do is there'll be two lectures. Okay, the next lecture, which will be lecture 2, will be a review of what we discussed on chapter 20, and which was what is the direction of the magnetic field around the current, and what is going to be our case. We'll have a wire in this loop. Now it's going to be a circle. In this wire, we'll have current, okay, current going around. And we know that current creates a magnetic field. How do we find the direction of the magnetic field? We use the first right-hand rule, which tells us, oh, your thumb has to go in the direction of the current, and then you use your 4 fingers to try to get the direction of the magnetic field. Now, so all around this wire, we'll have circles indicating the direction of the magnetic field. But it's going to be much better to see this lecture 2, because there I try to do some little demonstration to try to make this, trying to make clear the direction of the magnetic field. Okay, lecture 3 will be based on this slide, but I'm not going to be showing this slide. Lecture 3 will be again some sort of demonstration, and the discussion on lecture 3 is, okay, so change in magnetic field produces current. what is the direction of this current and why. Okay, so this is going to be the subject of lecture 3. The direction of the current is always the induced current. Okay, so the direction of the induced current is always trying to oppose the change. Okay, always trying to oppose the change. So you will see the direction, the discussion of the direction in this lecture 3, and then again in lecture 4. Lecture 4 is going to be about this slide here. Okay, so I suggest that you watch lecture 3 and lecture 4 and go back and forth until you're sure you understood the subject.